This is an LED matrix. It is driven using an Arduino Nano alongside two shift registers. These shift registers are chained together to create a 16-bit parallel output. The first shift register, the TPIC6C595, is used to control the LED anodes, which correspond to the rows of the matrix. The second shift register, the 74HC595, is used to control the cathodes, which correspond to the columns. Each LED on the matrix has a unique cathode-anode combination, which allows any LED to be singled out and turned on. This is called multiplexing. Multiple LEDs in the same row or same column can be turned on with one anode and multiple cathodes, or vice versa. However, a problem comes up when trying to turn on LEDs that are in different rows and columns. This will always result in more LEDs turning on than desired. For example, if I turn on 0, 0 and 1, 1, it will also turn on 0, 1 and 1, 0. The solution to this is persistence of vision. Turning on and off different LEDs faster than the human eye can see creates the illusion that they are all on at the same time, like the pages of a flipbook. This allows us to create a system in which each anode of the LED is turned on in sequence while turning on the desired cathodes for each row. This system lets any 8x8 image be displayed on the matrix. An application of this system is to display text using an 8x8 ASCII font. ASCII is a universal database of 128 characters. This font is 1024 bytes long, 8 bytes for the 8 rows it takes to display each of the 128 characters. Since this would take up half of the Arduino Nano's 2048 bytes of RAM, this font is instead stored in EEPROM, a type of non-volatile memory that remains the same even when power is disconnected, unlike RAM. The font now needs to be read from EEPROM and displayed on the matrix. This is done by taking the ASCII index of the desired character, multiplying it by 8, and displaying the data of that EEPROM address on the first row of the matrix, followed by the next 7 bytes to display the whole character. A problem comes up when trying to display multiple characters in the sequence to create a message like this. There needs to be a pause in between each letter changing, but not one where nothing is done, which is what the delay function does. This can be solved with interrupts, which do just that. They interrupt the code that is currently running and run something else when a certain condition is met. The ATmega 328P, which is the processor on the Arduino Nano, has a built-in timer that can be used for this. The timer will begin when the program starts running and call an interrupt service routine, or ISR function, every 1 second, which will change to the next character in the message. Another application of the LED matrix is to create animations. In this animation, the LEDs race across the matrix, each row growing towards the right. For any given row, there are 2 important values: the current byte displayed on the row and the value of the rightmost bit. Every second, the row has a 50-50 chance to move, determined using the random function. If it does move, the rightmost bit, which will start at 128, is bit shifted to the right by 1, so 128, 64, 32, 16, 4, 2, 1. I missed 8, 8, 4, 2, 1. And it's added to the currently displayed byte to make it look like the row is growing. So if you have 128, just 128, it'll take 64 and add that, then you get the first 2 lights lit up, and that's how you get the growing effect. So when a row makes it to the end, it will flash on and off like that to show that it is the winner. And this demonstrates another way that a task can be performed for a certain amount of time before moving on, which is millis. The millis function returns the number of milliseconds that the Nano has been running for. By subtracting a timestamp from the current time, a time interval can be checked repeatedly until it passes a certain point, such as a second, when the loop stops.